to today's Energy Central Power Session entitled Grid Services, Defining Operational Needs and Performance Expectations. A few housekeeping notes we'd like to mention. We acknowledge that given the higher demands on internet connections where many are working from home, technical issues may be more pronounced. If for any reason we find the need to restart the event, we invite you to click your same link to rejoin us. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the left-hand panel of your interface under the audio section. After introductory comments from our panel, we will engage in a discussion led by questions from our moderator and from you, our audience. To participate, we invite you to submit your questions at any time using the interface on your screen. I am PJ Davis with Energy Central, acting as your technical facilitator. I will drive. We have a couple of contextual slides to share with you today, and I will help you with anything that might come up. But now I'm happy to turn the floor over to our moderator, Dick Brooks, to kick things off. Dick, welcome to the event. You have the floor.
Hello, PJ. Hello, everyone, and welcome to today's power session on grid services. This is an area that's really just blossoming at this time. You saw the FERC filings this week from the ISO and RTO community. You'll see that grid services are becoming an absolute requirement moving forward into new as the energy transition evolves. So this topic is timely, and we're very fortunate to have some true experts in this area from the Department of Energy and from the ISO RTO community. And so with that, I'd like to invite our panelists and of course thank our panelists for being here. But I'd like to pass it on at this time to each panelist to introduce themselves. Chris, would you like to kick us off?
Happy to, Dick. Chris Irwin with the Department of Energy. I work in the Office of Electricity, which specializes in grid R&D and grid issues in general. But really, there really isn't an organization within DOE practically that isn't involved in the grid right now. It's subject of a lot of forces that society is bringing to bear on it, whether it's decarbonization or climate change, or transport electrification. So there's a lot of forces acting on it, and so we find the need to speak to a broader audience. Like I said, I work in the Office of Electricity. One of the ways that we collaborate across program offices is through the Grid Modernization Initiative, and the work under this title has been pursued collaboratively across the DOE. So with that, that's the end of my intro. Thanks, Dick.
Thank you, Chris. And Rich, would you like to go next?
Yeah, I'm Rich Brown from Lawrence Berkeley National Laboratory. We're one of the Department of Energy national labs, the lab complex based in Berkeley, California. And I'm in the Building Technologies and Urban Systems division there. We do a lot of work on making buildings grid interactive and technologies for doing that. So one of our projects is part of the collaborative grid modernization initiative that Chris mentioned. We're working on communication standards for how distributed energy resources can interact with the grid in standard, replicable ways. And so that's kind of given birth to this, this effort on standard grid services that we're going to talk about today. So thanks.
Thank you, Rich. And Joshua, last but not least. Oh, you're on mute.
Thanks, Dick. I'm Joshua Phillips. I work with Southwest Power Pool. We are an RTO responsible for transmission planning, market administration, reliability coordination, and other services for our 115 members. Our mission at SPP is working together to responsibly and economically keep the lights on today and in the future. As part of my responsibilities at SPP, I work with standards organizations like the North American Energy Standards Board, which is also known as NASB, where I chair the Wholesale Electric Quadrants Executive Committee and Business Practices Subcommittee. These two groups are the ones currently addressing the DOE and National Labs requests regarding grid services. Just a little bit about the NASB activity. NASB's been an active standards organization development for almost 30 years. and is accredited by the American National Standards Institute. NAESB also serves as a forum and focuses on the development of standards to promote more competitive and efficient natural gas and electric markets, as well as streamline the transactional business processes of those markets and industries. I personally see one of the great values in the NAESB process is its approach to stakeholder-driven processes, which results in successful adoption of its consensus-based standards for industry. And I'm looking forward to the continued successes there as we move forward with the development of standards associated with these grid services. Thanks, Dick.
Thank you, Joshua. And okay, so as you can see, we do have some truly expert people here for you today to talk about grid services and help guide you as we start down this journey. As you see, my name is Dick Brooks. I'll be moderating today. I'm also a longtime NAESB member from actually since 1995. So it's a great organization and they do really good work. And we're happy to be working on this grid standards framework and on behalf of DOE. So thank you for the opportunity to work this in with you folks. Okay, we've got a few questions we'd like to start off with. Let me go ahead and get that started. So this question is for Chris. What are grid services and why is this work important?
So I think we can go to the next slide. I have the luxury of trying to tee off the big picture. Is that I think everybody in the audience has an idea of what grid services are, and the good news is you're right. However you define the thing that you care about, is that there is a traceability to grid services here. The thing that we've acknowledged over and over throughout our industry is that there are many names for very similar services. Sometimes the name came from the first asset that ever provided that service, but it's got a varied landscape to it. And so these are sort of the most popular names that have been attributed to grid services. But when you look at it, especially in the context that's emerging now in prosumers and transport electrification and all these interesting dimensions at the grid edge, is that customers may have their own terms for grid services. So if we could move to the next touch of the slide forward, is that customers have names for energy services as well. And they can be elucidated, and this is just, of course, the beginning of the list. But the most important thing, really the substance of the work here by the national labs and by NAESB, is that we really do have something in common. And to a certain extent, I attribute it that the best analogy I have is to with the flavors, is that there are actually a very limited number of flavors that could describe all of the foods that are available to us. And of course, we know that we have infinite variety of foods and things like that, but researchers have attributed a few foundational elements through which you can compose any flavor and any food representation. And so with that, we can go to the next point of this slide, which is what the Energy Services Interface team has identified as foundational grid services, really as seen from that DER perspective. But the important thing to understand is that if your favorite word for a grid service did not show up in the operational grid services column or in the customer energy services column, there are dozens of other terms that people give to these grid services. And so what the work is going to describe today is the fact is that no matter how you name it, is that it can be reduced to either a single component grid service or a combination of these grid services. And so if we can trace all of our subjective experiences of energy services back to a common lexicon with very few words in it, we're in a very powerful position to articulate how to be interoperable across the standards world, across the states, and really across the world. So with that, I'm going to turn it back to Dick. Thank you very much.
Thank you, Chris. I think that was very helpful. And now we'll move on to our next question. Okay, so Rich, this is for you. Please describe the DOE GMLC initiative that this work is part of.
Yeah, thanks, Dick. So I mentioned in my intro that we in the National Lab team community are working and really helping DOE with their mission of making distributed energy resources among many missions. There's one of DOE's goals is to make distributed energy resources more common, easier to integrate with both buildings, existing infrastructure, and with the grid. And so one of the barriers to that the lab team has been working on for several years is this idea of interoperability, or the idea that in communicating and coordinating the actions of all these distributed energy resources, that there's just a high burden or a high cost to integrate these, do the communication integration. Each integration is kind of custom or one-off. And so we've been working on a common interface called the Energy Services Interface that would allow grid entities, whether they be at the transmission or distribution level or some sort of third-party aggregator, to coordinate with groups of distributed energy resources. And so a fundamental part of that is expressing the services that the grid wants from these assets. And really the idea here is that this doesn't just apply to distributed resources, but also centralized resources. So as Chris was just mentioning, the same service that an energy service that a large hydro plant is providing, or a nuclear plant, the energy service is the same as might be provided by a rooftop solar system or a behind the meter battery. So what we've tried to do is kind of distill these services down into that fundamental essence that then can be used as the basis of standard types of communication for the purpose of coordinating all these assets. Yeah, thanks, Dick.
Thank you, Rich. And we'll move on. We have a question now for Joshua. Who is the intended audience for these grid services, and how will this standard change the way things are working today on the grid?
Great, thank you. It's a great question. I think as far as the audience for the grid service standards, NAESB standards are open for all. Right now, we're focusing on the wholesale electric quadrant, which is going to be primarily dealing with the bigger bulk electric system, large transmission system, interfaces with RTOs, and so I see that as kind of the first audience that's looking at this, and that might be able to see some help bring some of these into focus, some of these ideas. More importantly, I think the bigger audience is going to be the distributed energy aggregators, or those buildings that are looking to integrate into the wholesale electric market. But right now, there is a very, a very varied terminology across the RTOs. We all have very similar, at the macro level, it's the similar application of electric service, energy service. When you get down to it, there are some nuances that will still exist across the RTOs as we're all developing our markets based off our memberships and implementation and regional differences. But having this lexicon of terms that will provide a basis for understanding and knowledge associated with these different dimensions of wholesale electric service will benefit, I think, most the general public who may not have that intimate relationship with RTOs and the bulk electric system, but may have some products that they could offer to that system.
Okay, thank you, Joshua. And I think you hit the nail on the head there. I think we do see a lot of differences across the ISOs and RTOs, and I think there was no better proof point to that than what happened with Storm Uri back in Texas, which caused a huge number of blackouts there. But as I recall, SPP handled the situation quite differently. And so your point about differences across the country and some of the challenges with trying to manage the grid as it evolves are, I think, are prudent. Okay. And PJ, do we have any questions?
Let me check here. Nothing yet from
Dick,
the,
we're looking for
from the
that. I could
audience.
probably amplify a little bit also on the kind of intended uses. Um, you know, Joshua kind of represents the, you know, the transmission level. At the distribution level also, in some ways, there's even more need for these sort of standards because we don't really have organized markets like we do in transmission or, you know, independent system operator type markets. And so there's a lot more variety between, you know, every distribution utility has different programs and things like that. And so trying to harmonize, not that everybody's going to be doing everything exactly the same, but having kind of a common basis for defining these services. The hope is that then it's easier to, you know, plug your battery in and actually coordinate with the grid in California as it is in Oklahoma or in Georgia. You know, that's kind of the idea, is making these integrations easier wherever you are in the country.
Thanks,
Yeah.
Rich. And let me remind the audience too that you are welcome to submit your questions anytime or your comments into the box right there on your screen. And we're excited to see what you all have in mind. Dick, that's all for now. No comments quite yet.
Thank you, PJ. And Rich, that's a really good point. Thanks for bringing that up. That, you know, the electric grid is not just about the transmission level, it's also distribution. And the lines between distribution and transmission are blurring. We're starting to see a lot more supply making its way onto the distribution grid. And you see that is, in fact, a very big factor in, you know, how the grid will be operated in the future. And I think that was really on full display when you look through the comments that were filed with FERC. FERC recognizes that these are challenging times, and they know that things have to change. And those filings that I encourage you to look at, they talk very specifically about the important role of grid services. So thanks for pointing that out, Rich.
Yeah, I think it could even apply to microgrids in you know, kind of the long term, that, you know, these same services are needed to run any size grid, essentially, whether it's a, you know, a regional transmission grid or a local distribution grid or a kind of hyper-local microgrid.
Okay. No, that's a good point. Thank you. And I just want to point out something that may be obvious to everyone, is that you'll see that my picture down below, that was taken earlier this morning. As you can see, there's a slight difference today. Just wanted to point out the obvious there. Well, it looks like we have a question. All right, let's go ahead. So how would a non-DSO understand what the grid benefits are needed on specific circuits? Aside from structured markets on economic dispatch, what are the standards and trends for developers to anticipate, craft, and deliver DERs for grid benefits? Anyone want to take that?
I could give it a shot. So the question was about DSOs. Did I hear that right?
Non-DSOs.
Oh, non-DSOs.
Non-DSOs, yeah.
So I'll start in, Rich, and then you can
Yeah,
fix
please.
what I'm going to say here, because it is an important observation, is that if DERs are ready, willing, and able to participate in the grid, they need the signal, they need the sign. And to a certain extent, most of the grid constraints, so most of the challenges of the grid are to date solved internally. And so if there's a voltage sag on a line or something like that, then a load tap changer receives that information and it bumps it back up to an acceptable voltage level. And so the answer to the question is that sometimes the grid operator knows that there's a deficiency and that they would like to remediate it, and they usually today do it with their own control services. There are other times where the grid operator does not know because some machine out on the line identifies the deficit and fixes it automatically. And so there are cases where not even the grid operator knows what its tools are doing at all moments in time. But part of this grid services language that we've evolved is not just to advertise the grid services that are required from the edge of the system and to ask for assistance, but it's for really grid operators themselves to synthesize their needs, their challenges into things that can be solved collectively. But I don't think we have that language just yet. That's kind of the substance of our work. And then Rich, you can probably dial that back to a more realistic.
So for non-DSOs, I'm guessing that means kind of traditional
And you
vertically integrated utilities or more traditional regulated distribution utilities. And we see this even applying to demand response programs, for instance. We started off here mentioning generators and batteries and things like that, but loads like electric vehicles and traditional building or industrial loads can just as well. I think part of the goal of all this is kind of putting all this on a level playing field and clearly defining what the performance attributes that have to be delivered as a service, and then kind of letting the different players out there, compete essentially to provide that service. And another aspect of this also is to be able to the actual operation of the service, to do that in a more cooperative, or you could maybe even say voluntary way, rather than kind of a direct control approach, which is a lot of the way these things are done with behind the meter assets now, is they have to enroll in some program where the utility actually takes command of that asset, but rather doing it in a more decoupled approach where the service requester expresses their needs in kind of a quantitative, objective way, and then the provider, the DER or whatever the asset is, can then provide it, and it's measured and verified and settled. So yeah, hopefully that helps.
Joshua, did you want to weigh in on this?
No, I don't have anything to add. I think they've covered it very well.
Thank you. Yeah, and I think some of what's embedded in that question is really about situational awareness. It's how does an operator know what they need in terms of services? And this is an area that's becoming even more challenging. It's trying to look into the future and say what kind of services do we need, and how much of them do we need, and where do we need them? So these are all important topics that I'm sure will come up and be discussed as we continue our discussions in NASB on this. Okay, there's one more question I see. Let me see if I can get to that for you.
I think there's a few in the chat now.
Yep, so looking at Q2, looking for a common change story that can be used to explain and motivate the people, employees, and contractors working in utilities and RTOs, ISOs that now need to change their role definitions, their processes, and their behaviors. Is anyone working on that angle at the highest level, just as the technology is being worked on at the highest level? Any takers?
It mentions RTOs, ISOs. Joshua,
Yeah, I'm
opinion about that?
trying to think through that. That's a good question, and I don't know that there is a good story that's been developed or that exists that we could bestow upon everyone here, which would be great, but it's just not there. Right now, there is significant activity going through the RTO in response to, I see a couple other questions that mention, or another question that mentions 2222 specifically, as well as DER, and those implementation plans are being developed. There are filings going back and forth with the commission on how each RTO is going to address this. I think as far as developing that story for movement, that's going to be a regional issue that gets addressed by those RTOs, as they have to make their compliance filings and go through FERC processes. With that in mind, I do see some of this, the effort that is underway here through the NASB process and doing the standardization as being something that can help break down some barriers between communication for both the wholesale and the retail, to the extent those exist, and having these definitions that can flow up and down throughout the energy system, and switch between the distribution and the transmission in a simpler manner will be helpful to get that story developed and then told.
Yeah, I think there may also be an evolution in moving from the traditional utility construct where they have direct control over an asset to more what we're talking about, a service-oriented framework where they're requesting a certain type of performance, and there's some sort of agreement or contract for that, and then it's delivered, measured, and settled through some sort of financial mechanism. And so it's not necessarily the direct asset control model that we've had in the past.
Thank you, Rich. And we're sort of running out of time for this section of the presentation. We have a lot of questions.
We'll have time at the end also to come back and address some of these, I think.
Yeah, very true, Rich. I agree. And so with that, I'm going to move us on to the next phase of this, where we talk in more details about grid services themselves. So this question is for Chris and Rich. Do you have a list of grid services to be standardized?
Well, I think that brings us back up to my top slide is really, of course, all of those words that appeared on that initial slide, whether it was an operational grid service or all that word salad that you saw at the bottom, is really, that's the list that we started with. And really, can we distill it to something that's a little bit more foundational? So those services are sort of articulated around that, is that there's energy scheduling, frequency response, voltage management, emergency services, regulation, and reserve. And there's questions that come around whether it's are we talking just about transmission services or distribution services? And no, we believe that all of the grid services needs can be articulated through these sort of 6 fundamental elements. And I think part of the next description is the next part of our presentation is to go into these weeds and explain how an energy schedule service combined with the voltage management may produce the service that someone is looking for at the distribution level.
Yeah, I can add on to that also that the 6 colored hexagons in the middle there, those are the results of some research that the lab team, that the national lab team that Chris has funded to work on this. So we've reviewed what we can of the literature and kind of looked at some of the ISO and RTO markets out there and programs that distribution utilities run, and tried to kind of distill the common elements down. And this is kind of the initial kind of proposal that we came up with. And the value of working through NASB, through the standards committee, is really that this is just a starting point, and the NASB process allows us to get input from people in the industry who work with these things every day, and they can point out where we've gotten it right or wrong. And this will evolve somewhat as we wind through the standards process and get comments and address stakeholder feedback. But this is kind of the initial set that, based on what we can assess of what's out there today, seem to be the common categories of services.
Thank you.
And Rich, Dick, one more thing is, I'm excited to get into the next thing where we provide the audience some details. But once you have this fundamental language of a limited number of grid services, you can start asking yourself some pretty interesting questions. Is that what quantity of each grid service did you need in the past to run the grid? And how much of each one of these grid services do you think that you will need in a full decarbonization strategy, in a transport electrification strategy? So it's that simplification allows us to see our present tense in a new light, as well as the future needs of the system.
That's a really good point, Chris. And here again, I'm going to go back to all those FERC filings that we saw just this week. A lot of what you're describing is essentially stated very similarly to what you just stated there. That these things, these things are really these are real problems. That the grid operators face, and so you know, and especially in light of some of the changes, is a question, and I won't go to the question, but I'll mention it here that FERC Order 2222 really did change the playing field for the ISO and RTO community. And I don't know if Joshua, did you want to? I know you've done some work in the FERC 2222 area. Did you want to just take a moment there to tell us a little bit about how you see that impacting things?
I don't really have any comment on that one, Dick. But I appreciate that opportunity. I hate to speculate and start going down any paths. We got an open filing with the commission right now, so I mean, there's all sorts of new flexibility that could open up, and yeah.
Anything you say can and will be held against you.
Yeah, and that was just one of the questions in the chat. I thought I'd just open that up in case anyone had any thoughts on that. Okay, let's move on to the next item. So, so here's a question for Rich and Joshua. How do you distinguish the different grid services?
Yeah, so going back to what I just mentioned about how coming up with those 6 kind of basic categories, we reviewed the literature and we came up with, you know, essentially a methodology for just, you know, for categorizing the different products and programs that are out there. And actually, PJ, if you could bring up that next slide, I have a summary of how we've defined these things. So the idea here is that these are performance-based grid services. And so, you know, they distill, or they kind of embody what the grid operator is looking for in terms of performance, and we've defined that on kind of these 3 different axes, really 2, and then a way of measuring them. So the first is electrical, because obviously the you know, the grid is transmitting this physical commodity of electrons, and so you know, the basic attributes really are how these you know, how much of the electricity is being delivered, quantities, and also the qualities, whether it's real reactive power, energy, voltage, and over some performance period. And then the other attribute is where it's actually delivered in the grid. So those are kind of the basic electrical attributes. And then there are various timing attributes as well. There's a delivery schedule. There's some sort of a notification period that the grid or the service requester provides to the entity delivering the service. And then there's often some sort of response time. And I should say that not every one of these attributes is used to define every grid service, but this is kind of the universe of kind of major attributes. Obviously, there are a lot of details, and we've tried to kind of abstract away from those so that these can be yeah, not universal necessarily, but you know, generally applicable. So the response time is something about how quickly the service can be delivered once the service provider is notified. And then the third area down there is about performance determination, about how is the service actually either measured or estimated. Usually it's based on some sort of a measurement, but often there will be some additional estimation applied on top, whether it's line losses or meter accuracy or things like that, that may affect the final quantity that's actually used for settlement. So this is kind of a framework that we've developed to try and describe these services, and this is part of what's being worked on in the NASB committee that's working on this standard. And Joshua, you might want to add on to what I've said here.
Sure. Yeah, I think you covered it really well. That we are basically taking all of the 6 hexagons from the previous slide and trying to break those down into common parameters that would generally apply to those different services, so that we could develop that common terminology and language as we discuss this in a broader audience than just the wholesale electric quadrant. Subsequent to the wholesale electric quadrant's activities regarding standards, there is an action item for the retail markets quadrant to address these as well, which I think we'll get into more of this DSO dimension of what it is that the distribution system needs and how they evaluate these different services. And I think that's actually going to be one of the more interesting, given the number of distribution utilities versus the number of RTOs. We're talking non-RTOs in the country, or North America rather, versus several thousand utilities and cooperatives, et cetera. So I think in addition to the ability to speak these common terms at the wholesale level, you'll also have a lot greater understanding at that retail level, and I think that will be part of the story that gets developed to help enable additional grid services and participation from those newer technologies, the solar panels on the roof, the Tesla Powerwall, all these new things that are coming out, but fitting them into the system and making sure that we're able to capitalize on the benefits and economics associated with that flexibility, I think will be key as we move forward.
Thank you, gentlemen. There is a question in the chat that I'd like to share with you at this time. Does an increase in inverter-based resources create new or additional service needs? What about inertia?
I could say something about that. So the inverter-based resources don't necessarily, not in and of themselves, change the amount of services needed, but it does point to a need to move towards this more performance-based description of the services that are needed. And inertia is a good example, right? That the service is part of the regulation hexagon that we talked about, and people have talked about artificial inertia or services like that. But if we can boil it down to actual specific attributes that define kind of physically and the timing of that service that's needed, then as long as an asset can qualify to deliver that service, then it shouldn't matter if it's inverter based or rotating machinery or a battery. I guess battery is inverter based, but so that's part of the goal here, is to kind of abstract the discussion away from physically what's providing it, what asset, to what is being provided to the grid, the actual physical parameters of that.
Thank you, Rich. We do have one more question in the chat. So it's a little different from what we've been discussing, but I'll go ahead and throw it out there for your consideration. The performance definition of grid services has implications for regulatory reform in terms of utility business model, rate design, and pricing, and performance-based metrics. Are you coordinating with regulatory decision makers on the implications of your standards development efforts?
Wow. So, Rich, you might get left holding the bag on this one, but I think that what DOE charged this team with is to try to create a standards agnostic, so it could speak to OpenADR, it can speak to IEEE 1547, it can speak to 61850, but is a standards agnostic expression of what energy service, what is actually being asked of. And so this is before you have sort of physics measurements to it. I don't believe it was the intent of the organization to have any regulatory implications. And so an energy schedule is an energy schedule and a voltage service is a voltage service. I think it could be that the question gets at is that if a utility is no longer the entity that maintains the meters, poles, wires, and transformers, but the entity that synthesizes some of the grid services that it needs within its own asset base, and then obtains the grid services that it needs outside of its own asset base to accomplish its regulatory mission, there are certain understandings of that need to be rethought in that regulatory context. But I don't believe the ESI work was thought to have a regulatory influence per se. It's really more to free up people to speak about these challenges.
Thank you, Chris. And I do know that the NASB process encourages participation by regulators, state and federal. And I know that NARUC has been an active participant in NASB in the past. That is correct, right, Joshua? I think I got that right.
Yes, we do have several, at least some regulators participating in the NASB process, and it is open participation. So to the extent that you're aware of a regulator that needs to plug into this, they are more than welcome to come join the NASB meetings and discussions. And I do see there being potential impacts down the line as more of these things get codified or common definitions. It should be across the industry that those terms are picked up and leveraged as things move forward.
Thank you, Joshua. Okay, let's go back. I got another couple questions here. Can you provide a scenario describing how these services would be used in today's grid?
Joshua, you might be able to, do you have an example in SPP that?
Yeah, so as these additional resources become available and are looking to get incorporated into our system, we have numerous processes, but having that base understanding of what services we would look for and what those services look like from a standards perspective would help the parties that are interested in trying to figure out how to leverage the value of the resources that they hold, how those fit into the markets. Coming into those discussions with a greater understanding would improve the outcomes and probably streamline the process as it moves forward. We see that potentially as an exponential addition of resources, if depending on how things move forward and all the different things that are happening in the energy environment right now. But with the slower pace of things, questions coming in, it's not terribly challenging. But if you had a whole numerous large number of people with rooftop solar coming in to ask about providing energy service, that could create a bigger backlog and challenge to how to address those questions. But having this common nomenclature around what they're looking to provide to SPP's markets would enable streamlined process there.
Thank you, Joshua. Chris, Rich, did you want to weigh in?
Well, I can say we've talked to a couple different ISOs around the country that are undertaking kind of grid modernization planning activities around increased renewables penetration, things like that. And they're talking about moving to more of a kind of general grid services framework. I think Chris mentioned this, right? That, you know, in kind of a planning mode, it's good to know how many of these different services you actually are going to need to procure to be able to know, you know, how large, you know, kind of what your procurement timeline is and things like that. And so, you know, we've heard that thinking about them in these more kind of general categories rather than saying we're going to build a power plant of a certain size and capability, thinking about it more in terms of the services that a power plant might provide, and then doing a procurement around the services.
Thank you, Rich.
Yeah, so that's more of a planning construct than an operational. I mean, you know, initially we thought about this more from the operational standpoint about, you know, day to day as a grid operator actually operates their grid, how are they mixing and matching these different services to keep the system balanced and stable.
Thank you, Rich. And we do have a question from the audience. How will this impact home PV systems?
Well, we hope to make this a more open definition system where, you know, the thing that we are confident of is that we can't predict the next wonderful thing that's going to happen to our system. And so it's not only that we're trying to improve the liquidity of generation from any source, be it from a solar panel or from a wind farm or things like that, but is that we actually cannot predict the next thing that's going to be a major impact on the energy system. So really, our effort is to make this as generic as possible and applicable as possible so that we don't have to know in advance the next new technology that's going to hit the grid. We know that it will speak one of 6 languages in terms of the grid services and things like that. So whether it's a power flow controller or something that we haven't thought of, is that it can be broken down into a recipe of grid services, either as one requesting grid services or one supplying them.
Yeah, I think the you know, there are interconnection standards for yeah, home PV systems that are, you know, just from a kind of a safety and reliability standpoint. We're not talking about replacing those type of standards with this, but people have talked about using you know, being able to control or, you know, kind of coordinate home PV inverters in the situation where when you have over generation, let's say in the distribution system on a particular feeder, and so you get an over voltage situation and the utility needs to somehow you know, curtail the generation that's going on there or increase demand. We've thought that these services could be a mechanism for the utility to you know, procure these services, whether it's curtailment of you know, having inverters curtail their production in some sort of a more optimal way, I guess, rather than some blanket, you know, everybody curtails a certain amount. Maybe the ones that are better able to curtail would be the ones that do, or to signal that it's a good time to increase load on that feeder. So, you know, EVs, for instance, that could increase their charge rate, they could soak up that extra energy that's being produced. So that, you know, in some future system might be, you know, kind of a vision for how these services could be used way out at the edge of the grid and, you know, in a distribution feeder.
Thank you, Rich. And that's a good lead into our next question, which is, do these services apply to transmission or distribution operators?
Everybody. Yes,
That's
that's
Chris and Joshua, please.
that is the aspiration to a certain extent, is that, you know, and so in that initial slide that I spoke to, we even had sort of, you know, customer energy services. And so, you know, whether it's Tesla or General Motors that just announced that it was going to become, you know, not just a transportation company, but an energy services company, is that in a perfect world is that GM could be as comfortable expressing the services, the energy services it can provide to the customer and the grid using this language as a distribution operator, as a transmission operator. So it might be a tiny bit aspirational, but that was the intent.
It could also be the basis of this concept of transactive energy that you know, a lot of people talk about, kind of aspire to. This idea that you know, the balancing of energy can be done kind of in a, you know, in a real-time way using economic principles, such that, you know, the grid players, or, you know, the assets that are best stable, or, you know, kind of most cost effectively able to provide a service can be the ones that do that. And I think those sort of markets depend on this type of you know, kind of clear, objective definition of what the service is, what product is being transacted, essentially. So this is, you could think of this also as a stepping stone to the kind of transactive energy vision that a lot of people have for both within the distribution grid and also at higher scales too.
Thank you, Rich. And that's actually a good lead into a question that's in the chat. So I'll go ahead and read that to you. Within the general categories of services illustrated on Chris's slide, what are the subcategories of services that will be examined and defined?
Well,
I think, yeah, go ahead, Chris.
No, I was going to say, Rich, I think that if we have more definition of the services themselves, the deeper dive, obviously NASB is not, you know, is not contemplating the graphic that we put together. NASB is, you know, contemplating a much more thorough description of these services and things like that. So I'm not so sure that those services, I don't believe that they become sub-services. They become service with this temporal definition, this locational definition, this time definition. You know, it's really it's not the flavor that you're changing, it's how you're using it in the recipe that changes. And so what are the nuances that you then go on to define is this service with these performance attributes.
Right, it's kind of like common parameters used to define a given service. We're not saying that everybody's going to have the same value for those parameters. So, you know, an energy, like a day-ahead energy market, you know, it has certain parameters about how you measure the energy, you know, or how it's quantified, what the time periods are, how the locations are defined. But SPP might have a different way of defining, for instance, the electrical location of, you know, where it is in the grid compared to PJM or, you know, another grid operator. But they still have the notion of an electrical location that helps define that service. So that's kind of what we're talking. We're kind of talking about common fields to define the services, and the values within those fields may vary or will vary between different grids, different markets, you know, different products being defined.
So I guess what I'm hearing there is that an electron is an electron, regardless of where it comes from. And I guess what you're saying is the real distinction is in, you know, some of these attributes that you describe, or characteristics, that really separates them as far as, you know, what they're providing. Did I get that right, Rich?
I think so, yeah. And going back to Chris's original slide on this too, is this idea of kind of composing services. Because if you think about what's needed to operate the grid, you know, let's say a transmission operator, there's many different products they use, and they kind of mix and match those to keep the grid stable and reliable. And so if you think about mixing and matching these kind of more generic service categories, I think that's just kind of an extension of how the grid operates today.
Oh, great explanation. Yeah, I know that some of the FERC filings referred to ramping as an example, ramping up, and I think to your point, it's just electrons that are being provided. It's just a question of those characteristics, those performance characteristics that the grid operator may need that really is going to help define that. Thanks. Okay, let's go back here now. Okay, let me just do a quick look at the chat. Okay, we got another question for you. How do you think your work will affect the evolution of a new distribution system operator model?
I keep trying not to chime in, and I apparently I have a problem. But we're trying to refine and simplify this language so that you can basically put a set of responsibilities. And so the distribution system operator is a new label for a set of responsibilities in the grid. And so really it was just used to be the distribution utility. But the distribution system operator is now part of that presumption, part of that, the semantics behind that label is the fact is that they are a convener of services. They may not be the sole provider of those services. So we think that through this grid services language, you should be able to articulate what are the responsibilities of a distribution system operator. I think that it's important for the audience to understand is that really what we want to do with these grid services is to promote interoperability between standards and between DERs. And so I don't care if it's a dedicated beer refrigerator or an F-150 Lightning or a solar panel. If you can speak to the same language to the grid of what your capabilities are, what you're willing to do, and what you're willing to take from the grid, then that gets us over the hump. But I think that from a DSO, from new operational models, it can be expressed to a certain extent in terms of grid services, but there will be other attributes that you want in terms of solvency, responsibility, and other things that are going to fall outside of a grid services domain.
Yeah, I think the DSO concept is getting at kind of non-discriminatory access to the distribution system. And so I think having these standard definitions that are more about performance rather than the financial arrangement or what physically the asset is, that is that's more consistent, I guess, with those non-discriminatory kind of open principles that people have for the DSO.
Thank you. And there was a follow-up.
There's a related question actually about why peakers are paid more than storage, which I think gets to this point that essentially they should be, let's put it that way, compensated for the performance, for the physical services at a certain time, at a certain location that they're providing to the grid operator. And by one of the kind of goals of having these standard definitions is that we can get more towards compensating them for the performance value they provide rather than whether they happen to be a gas peaking plant or a storage asset that's behind the meter, or that ultimately, like you said, Dick, if it's electrons at a certain time in a certain place, with a certain advance notice that they're going to be delivered or taken off the grid, then that should be what they're compensated for.
And that would, I think, lead into a very long discussion about locational marginal pricing and uniform
Yeah,
clearing
right.
prices, and probably a little beyond the scope of what we
Yeah.
can cover here today. But there is another question I'd like to go ahead and put on the table. How are batteries being broken out for balancing value and efficiency gains of whole systems?
Well, I'm not so sure that fits in our conversation. It's a good conversation to have. But so one can define the capabilities of a battery acting through an inverter touching the grid. So we could express that in terms of grid services capabilities. It's going to have magnitude and duration and time and location. I'm not sure that we can talk about the rest of the case that the question implies. That's maybe a little bit beyond this conversation.
Yeah, that's a good point, Chris. You know, we talk about batteries, there's all sorts of implementations, right? There's the Tesla Powerwall sitting in someone's house that could potentially be aggregated, and then there's the big grid storage battery. So it's a really big topic. I agree with you.
We certainly anticipate a proliferation of pervasive storage at multiple scales on the grid. It's essential for a decarbonized system. And we can express it in grid services terms. There's just more to the story, I think.
All right, thank you, sir. Anyone else would want to chime in on that?
And Chris
Okay,
covered it all.
Okay, great. Thank you, Rich. All right, in that case, I'm going to move on to the next set of questions. So this will take us down toward the end of the session, but what are your plans for the development of grid services? And that's for Joshua and Rich.
Go ahead, Rich.
Yeah. Did you want to go first?
Go ahead.
Okay. Well, I think our immediate plans are working with NASB to both in the wholesale electric quadrant and then in the retail quadrant, more on the distribution side, to standardize these services, and then ultimately what we're trying to do is incorporate these into what we're calling a specification for an energy services interface, which would be used to inform standards like OpenADR. I know there was a question in the chat about OpenADR. Another is the Smart Energy Profile, which is an IEEE standard number 2030.5. And these are standards for grid to distributed resource communication. And our ultimate goal is to make those standards more interoperable in the sense that if a grid operator wants to be able to access these distributed resources, that there's kind of a more standard profile for how they would communicate with these assets in implementing a demand response program or some sort of a DER distributed market, transactive energy system, various kind of use cases for it. But the idea is that those communication standards can be used as the basis for this standard form of interaction between the grid operator and DER owners.
And I guess kind of reflecting on some of the plans is from an RTO perspective and working with the NASB process. I would envision this being something that SPP is participating in the development of at NASB to help ensure that entities interested in participating with SPP could come through the NASB standard with that common definition and those common terms understood. I think to the ESI perspective, depending on how that gets implemented or adopted across industry, and those distribution assets could potentially flow up into the wholesale market, and having those standard approaches to those terms and different systems increases efficiency. So
Thank you, Joshua. And there was a question earlier in the chat that I think may be germane to this as well. Let me just go ahead and read it to you. From a first order principles perspective, is it fair to say that balancing any grid only requires balancing these three dimensions: energy, voltage, and frequency?
No.
it seems a little bit simple.
Well, yeah, it basically is like, I think that what you need to do is put time into the equation, time and place. And that basically, it doesn't increase the size of the problem domain. It makes it dramatically bigger, because it's not just time as in time along the continuum of history. It's time as in terms of interval of when you're notified, when you should act, interval for how long you should act. And so there's more dimensions to it. It's a very good start with the physics, but you have to have time in there, and that's where it gets fun, I think.
And then the other element of this is, people aren't doing this for free, right? Entities providing the service want to be, compensated for it. And so these services would be the basis of a whole, contract or some sort of service agreement that would include, there's the physical side of it about what's being delivered when, but also, the measurement methods, how the verification of that it was actually delivered, and then the settlement or the compensation mechanism. So the services are kind of one layer, the physical services, but ultimately this is part of a bigger framework or an agreement, I guess you could say, of how the service is actually delivered and compensated.
And then
Very much.
don't forget the regulatory schema that underlays all of that. That's
right.
I think that's where some of these common terms is going to be very helpful for. We've got 50 state utility commissions. We've got jurisdictional issues. So all adds up.
Yeah, and I think we can look to Ohm's law for some light on this as well. I think current is one of those other factors that would also come into play here, and resistance and all the funny things that happen in an AC system. So there's a lot more to this, to managing this grid than just the basic physics. Thank you. Question.
I think it's important to note, Dick, that so this has been, a absolute best effort, very thorough. At least half a dozen national labs have participated, lots of outside participants and things like that. So we've turned over every rock that we could think of and made this as simple as possible. So it doesn't preclude that there's going to be a simpler way to speak to the system in the future, or that there won't be yet another service that's conceived of that is completely differentiable from the others. And so, going back to that analogy of the flavors that describe food, there were only 4: sweet, sour, bitter, and one other, and then they added a 5th flavor about 20 years ago, umami. So it's like we may go down this road and find something new, but this is we think it's one of the best ways of discussing a difficult problem across time and space and stakeholders.
Thank you, Chris. And I think Rich nailed it earlier when he was describing the services, that you guys are really creating a common, like a lingua franca here, that you can define these services anywhere in the country and use them anywhere in the country, and they all have, same meaning. They may differ a bit in characteristics, but the concepts, the underlying concepts are largely the same. based and just differentiated by these characteristics. Did I get that right, Rich?
Yeah, yeah, and I think part of that, part of the motivation, I think, is, and this is particularly true for distributed energy resources, is that to really activate those is going to, at scale, when kind of millions of these endpoints, is going to require some sort of automation and machine-to-machine communication. And so you can imagine some kind of a digital tariff book, something like that, that would actually, digitally describe what's required to participate in a given market, or for some sort of transactive energy exchange, or any of these products or programs, that rather than having a printed or a PDF tariff sheet that describes all the rules, at least some of it can be boiled down, using some kind of common definitions like this, so that the two parties can have some sort of kind of not necessarily real time, but automated exchange of information to make this agreement, and to actually deliver the service. So that's part of our, kind of hidden motivation, not so hidden motivation, I guess, underlying all this, is to make it easier and more automated for, kind of plugging in your home battery. It discovers the applicable tariffs that it can participate under the grid, figure out, you can decide which one is most optimal for you, and then register, enroll, and start operating in that program. That would be a pretty nice situation. We're far away from that right now.
Yeah, that's a really good point as well. And well, I think what that really amounts to is a much more complicated system to coordinate, because when you get down into these behind the meter type implementations, you're really talking about the customer level. And previously the customer was just a recipient of power. Now they become engaged in the actual supply side, and also they're charging of EVs. So the customer part of this equation is just becoming that much more involved in helping to manage the grid. So, and so I think you're spot on there, Rich.
Yeah, one of the services in that original chart, that the hexagon chart that Chris showed, is called emergency services, which are, when the grid is really having, about to have an outage, or actually has suffered an outage. Part of the thinking there is, today there are black start contracts and things like that they use to restore the grid. But we could imagine using some of these distributed assets for doing that as well, either avoiding an outage in the first place, having some sort of kind of emergency operation mode, or after it's out, recruiting some of these behind the meter batteries and things like that to provide the black start energy to bring the grid back up, or at least help with it. Maybe they're not the primary source, but so I think this could be applied in a lot of different ways, but these general categories are, kind of show the way towards, doing this in the standard way.
Yeah, that's a really good point as well. And in fact, when I worked for ISO New England many moons ago, I authored a smart grid white paper. And one of the concepts that we described in there was the notion that some of these large parking lots, like here in Massachusetts, we have a very large subway parking lot called Alewife. And you can easily imagine a bunch of EVs sitting in that parking garage, providing some level of services. So yeah, it's definitely going to become a lot more complicated, isn't it?
Yeah, that's a good example. That the resource represented by a parking lot full of EV batteries is going to be enormous. That's going to be a central station power plant size.
Yeah, and when you think about it, you don't see coal plants get up and move around on a daily basis, but these cars and EVs do. And one other example we cited was, just imagine the challenge at the distribution level, down in poor sleepy little Foxborough when the Patriots are playing and their parking lot is filled with, 20,000 cars with EVs, that's a big challenge. So, yeah, I think the work you're doing is certainly germane to, the challenges ahead. Okay, let's get back into the program. What is the timeline for reaching a final standard, Joshua?
Well, NABSB is a member-driven process and it's open participation, so things can go very quickly or things can go very slowly depending on who's in the room and what kind of issues come up. But right now we've made some pretty good headway into the definitions with these initial 6, and someone had asked earlier about the different versions and subsidiary items. I think 6 is a good number. That's going to be plenty, at least for this first effort. But depending on how that goes, you never know. With regards to the NASB timeline, though, there is a goal right now of trying to get this through the NASB process by first quarter next year, so that we could include it in our next version of the NASB standards when they publish those. And we're targeting having an informal comment period later this year. I'll probably kick that off around November, solicit industry comments, and take that back to the subcommittee and review the comments, review the standards, see if there's anything we need to make modifications to, probably elaborate on some more things that we may have overlooked in the first cut, and then subsequently release that for formal comment period, which is kind of the phase before it goes to become a NASB standard in early 2023. So that's the goal right now. Things change all the time, so don't hold me to it if we're in March and we've had some epiphany that we had to make an adjustment to include. We do want to be sure we're thorough enough to not exclude any information that we need to be in the standards. So,
thank you, Joshua. And I know that NERC or Navy shares a special relationship with FERC, just like NERC does. Do you want to just take a moment and explain how NASB interacts with FERC?
With FERC or NERC?
FERC. How? That's
a lot of ERCs.
Yeah.
So NASB and FERC, they do work together. NASB does not advocate their standards. NASB doesn't go to FERC and ask them to, do this or do that, or here's our plan, we're going to do this, and lobby FERC to adopt the standards. NASB actually looks at their standards as voluntary. They are stakeholder developed, so requests typically come from stakeholders and come from other places as well. But once those standards get through the NASB process, the NASB board ratifies the standards as a new standard book, as would be the case here. That book would become part of the NASB publication, and when NASB does a publication, they'll also send a copy of that to the commission, so the FERC will receive a copy of that and notice that a new book has been published. And as often is the case, the majority of those books get adopted by reference for adoption or implementation by the industry, particularly those who have a tariff that is jurisdictional to the commission. So SPP, we have in our tariff a reference that says we adopt the NASB standards as adopted by the commission. And when the commission adopts new versions of those publications, they become mandatory for those of us who have the jurisdictional tariffs. So
thank you. That was very clear. Thanks a lot. And let me go back over to our set of questions. So this again is for Joshua. How can people participate and contribute to this work effort?
Yeah, so as I mentioned earlier, NASB is an open process. Any interested party can join in the calls and contribute to the development of the standards, provide comments, vote on what's in the standard, etc. There's no cost associated with that participation for NASB members. For non-members, NASB may have a fee that they would require to participate. It's usually a nominal fee, so it is an effort for the NASB process is focused on making sure that we can get as many voices in the room and contributing towards the work product that will be successful and adopted by industry. So for those interested, email nasb@nasb.org or go to nasb.org, and additional contact information is located there, and you'll be able to plug into those discussions at the BPS.
Rich, would this be a good time to bring up that other slide with the NASB resource?
Oh, yes, that is a good idea. Yeah, we actually have, yeah, PJ, if you jump back to that previous one, some links to some of these references that Joshua just mentioned. And these are hyperlinks, I know, but they will be distributing copies of these slides that will have the active links in there.
And so to that one question is that
there we go. It's in the chat for everybody.
Okay. The Grid Services work paper is, I believe, a product of the labs, but also lots of intense collaboration through NASB as well, because that's a really important part to get the buy-in from industry.
Yeah, actually, there was a question in the chat about this. Are there service definitions, work products publicly available today from the lab effort? And what I'll say about that is the labs, our initial take on this, which just represents, the lab's perspective. We do have, there's 2 reports that currently are still in draft form, but we're close to publishing one, and the other one will come out hopefully by the end of the year. And then, if you get in touch with me, I can put you on the mailing list for those. Those are work papers that we've submitted to the NASB process. And so the versions of those work papers that we've submitted are available on the NASB website at one of, I guess, the Grid Services work paper, right, Dick? That's the first link there. And those, through the committee work process, those kind of go through some modification, and we address comments and things like that. So the final NASB version that's adopted will be different than what the labs submitted at the beginning of the process, right? There's kind of a sausage making process that goes, between the input and the output. So
Fine making process, thank you.
Yeah, right. But at least the lab's kind of initial proposal will be, a publicly available report and, downloadable.
Rich, I only wish it was as pretty as the sausage making process. Sometimes these things get pretty wound up.
Yeah, how many flavors was Chris talking about that we can compose?
He's making me hungry. Come on. Oh goodness. No, that's really good. And as you can see, the links have been placed over there in the chat for folks. And Rich, I don't know if you wanted to put your contact information, because you mentioned something.
Oh, sure. Yeah, actually, I'm not sure I can chat to everybody.
If you type it in, I can distribute it for everyone.
Okay, that sounds good.
Awesome.
Okay, and we only have one more of our planned questions, so let me go ahead and get over there to that, and then we can just open it up to the audience Q&A. What are the next steps after the standard is completed?
So I can tell you from a NASB process what the next steps once we get that. That's probably the as far as I'm going to make it with the next steps. But for the NASB process, we'll have the mention that there would be a formal comment period early next year. That formal comment period feeds into the NASB process, where the executive committee for the wholesale electric quadrant would consider the standards proposal, and once approved, if approved, would go to the board for ratification. Publication follows that, and then goes back to the FERC comment earlier regarding adoption. NASB will also begin at that point their retail markets quadrant discussions around the grid services, and that will follow a similar process regarding the NASB process. But I think there's probably going to be more interest in some of the activities from DOE and Chris and Rich about where this goes after that.
Yeah, so actually the ESI effort, this GMLC project, is a successor to a prior effort, and it's really put, well, forgive the double meaning here, but it's put a lot of definition on the effort. We do have additional work planned. Obviously, transport electrification is a big deal because it's a very large load growth on the system, and a very different clientele. And so, as EVs proliferate and chargers proliferate and charging networks proliferate, there's an appetite to treat them as special, and they are special in many respects. But at the end of the day, they are distributed energy resources. They are resources to be served by our electric infrastructure, and they are resources to collaborate with infrastructure. So there's an appetite to look at the ESI work as it pertains to charging infrastructure, because as either Rich or Dick had said, is that you don't really see an ice skating rink that can pick up and move 2 circuits over and reestablish itself. But a Class 8 heavy-duty truck or a school bus is exactly that profile of load. And so it creates a challenge for the system, but it creates an opportunity to discuss our needs and our constraints in the language of grid services.
Yeah, I think from the lab perspective, we'll be looking at, just like Chris said, kind of looking at some of those applications for kind of pilot implementation of both ESI and incorporating this idea of the common service definitions. So we'll be kind of, trying to see, and obviously, yeah, EV charging, bidirectional charging also is one of the kind of main use cases that is motivating everybody to look at this. So, but more generally, the idea of flexible demand side resources, whether they be, electric vehicles or stationary batteries or other types of inverters or flexible loads, trying to do some sort of pilots around more simplified integration of those with the grid.
Thank you, Rich. And as I think Chris was pointing out, these things can move around. And as I mentioned earlier, poor sleepy little Foxborough, Massachusetts, with a load of about 1 megawatt on a normal day, jumps up to about 2.5 when the New England Patriots are in town just today. Now compound that with a whole parking lot full of electric vehicles. And oh boy, it becomes a real nightmare to try and manage that, especially if you're the distribution utility down in that area. So you guys are working on something that's absolutely necessary right now, and our grid operators are, I'm sure, they're going to be very interested in what you can come down with on it.
So we're working to make sure Patriots fans can get home after their football game. That's the
yeah, and make sure that there are plenty of Uber drivers around, because that'll be needed as well.
yeah.
Okay, so I think we're getting pretty close to the end, right, PJ? Are we just about there?
Yeah, we have 1 minute, so if anyone has concluding remarks, now would be a good time.
So I'll kick it off. Is that the DOE works through experts and works through communities and industry and academia and research, and so the energy services interface work would not be possible without the excellent contributions of the national labs, and for partners like Joshua and Dick organizations like NASB, the IEEE. So we really do appreciate the collaborative nature of this work, and I'm very pleased with the progress that's been made here. So thank you all for listening.
Thank you, Chris. And I'd just like to thank all of our panelists today for your excellent contributions. And of course, I want to thank our audience as well. And I would be remiss if I didn't say thank you to Energy Central for hosting this session for us. So thank you, Energy Central. We appreciate all that you do.
You got it, Dick. What a fantastic presentation. And for the audience, we hope you too have enjoyed this really engaging conversation. If you can please take a minute to fill out our feedback survey, which will pop up as you log off, and give us your feedback so we can continue to provide you with quality conversations just like this one. Thank you so much for attending, and this does conclude today's presentation.